Hello dear students, so this is our next topic, AC generator, which is alternating current generator. This is the last topic of electromagnetic induction chapter, and this is also the starting point of alternating current, which is our next chapter. Okay, so basically we are going to cover two things: the construction and working of an AC generator, right, and then the expression for induced EMF. Okay, so we start with principle. AC generator works with the principle of electromagnetic induction, right? What is the purpose of an AC generator? Its purpose, as its name, it is supposed to generate current, EMF, but the kind of current or EMF it generates is not direct. It generates alternating current or alternating EMF, which we'll understand when we derive the expression. So principle is electromagnetic induction. The detailed principle is, whenever a closed coil is rotated rapidly in a strong magnetic field, the magnetic flux passing through the coil changes continuously. Hence, an EMF is induced and a current flows in it. Very simple. So this is a diagram, right? So in books you may find little complicated diagrams, so I have tried to simplify the diagrams, and trust me, when the diagram comes in exam, you are not supposed to show your drawing skills. The diagram should be neat and clean, and you should nomenclate it. I mean, you should always name the critical parts, right? So to start with, there are two magnets, right, north pole and south pole like this, and between those two magnets there's a armature. This armature is nothing but it's a coil of many turns which is wrapped on a soft iron core. So this becomes our armature, and this armature has a shaft. Okay, so this has a shaft which can be used to, this is a shaft. This shaft can be used to rotate this coil continuously between those two magnets, north and south. Okay, now the two ends of coil, right, one and two ends, right, they are connected with these two slip rings, right, and these two slip rings are connected to two carbon brushes, B1 and B2. So slip rings can, basically slip over. These are the slip rings. So you can see this is a carbon brush, and let's say this is my slip ring, right? So the coil ka wire will come and connect on this slip ring like this. This is the wire of the coil which is connected on the slip ring, and a slip ring can rotate along the coil while touching over the brushes. So, okay, this is how it is set up, and the two ends of these brushes B1 B2 are connected to the output terminal where we want the output to be generated. Okay, so the purpose of armature is the main thing, which is coil, right? Why soft iron core? Because it enhances the magnetic field induced. Purpose of these slip rings, if these slip rings were not there, then as the coil rotates, after half rotation it may break the circuit, right? So while slip rings can rotate along the coil, while it maintain the contact with the brushes all throughout the rotation, right? As the coil rotates, these slip rings will slip over these brushes. So slip rings together with brushes maintain the circuit always closed. Okay, and this is how it works. Now I have just summarize the key parts here and put their basic function. We are not, see, this question will come for 2 or 3 marks, and in 2-3 marks they will ask you to diagram it, write the principle, and maybe derive for expression as well. So it's like for working and all, you are half marks, right? So don't go too much in detail. You can just write the way I have written, the same way you can write in the exam. Don't try to be too descriptive. It will not fetch you any marks, rather you will lose time and you will miss on the other part of the paper. Okay, so let's come to the expression for induced EMF and working. So for simplicity's sake, we have put the diagram like this. There is a magnetic field which is along the plane of the smart board, and perpendicular to it we have put the coil, right? And this coil can rotate. So you can just imagine this coil as like this. So this is my magnetic field, and the coil is somewhere like this, right? And it is being rotated like this. This is how it is being rotated, right? So we will, so at any given point, right, let's say the coil, if this thing rotates, let's say this is rotate like this is the side view, this is the side view of this coil. So with the side view we'll just see one side. So let's say the coil is now at, if I want to map this orientation with my notebook, it will map like this, right? So it is initially it is kept like this, perpendicular, the plane is perpendicular to the magnetic field, and then I'm slowly rotating, right? This is how it is. So at this time you can see, if it is like this, the plane, the area vector of this coil is like this, and the magnetic field is like this. So the angle between the magnetic field and the area vector is going to be theta, which is shown like this. I hope this is clear. So this is what we're saying, as the coil rotates, the magnetic flux changes as theta changes, because we are rotating the coil continuously, so theta will also change with time, right? So we have to start with some point. So we will say, consider t equal to 0 when the plane of the coil is perpendicular to the magnetic field. At that time this angle theta will be 0, right? And let's assume after a time lapse of t, coil has rotated through an angle theta. So if I want to write the magnetic flux, okay, so we'll assume omega is the angular speed of the coil with which it is being rotated. So theta will be equal to omega times t, right? Angular displacement is equal to angular speed into time, omega t. Magnetic flux at time t would be B dot A, so it will be BA cos theta. Now BA cos omega t. Now this is the flux. Obviously you can see there's a time here, so with time it is changing. So if the coil has n turns, the total flux would be NBA cos omega t. As per Faraday law, E is equal to minus d phi b by dt. So when you differentiate this NBA cos omega t, NBA is constant, so that will come out, and omega is also a constant. So when you differentiate cos omega t, it will be sin omega t with a minus sign, which will adjust this minus, and there will be omega as well coming out, right? Because this is a omega t thing, right? The differentiation with respect to time. So I hope this is clear. So NBA omega sin omega t is our final expression. Now when sin omega t is equal to 1, right? Because sin, this is like, function which changes with time, sin omega t, right? So there will be a time when sin omega t will be exactly 1. So at that time E will be E naught, that is maximum. At that time the EMF would be maximum because sin omega t is 1. So we call it E naught, right? This is also called peak EMF, and that will be NBA omega because sin omega t is 1. This is the maximum or peak EMF. So we write this expression as E is equal to E naught sin omega t because E naught is NBA omega. So please remember, the maximum EMF is always NBA omega. Not many numericals come on this. They'll give you N, magnetic field, area, and omega. They'll simply ask you what is the peak EMF, right? So for expression for the EMF, you have to reach till this point. E is equal to E naught sin omega t, and write E naught is NBA omega. E naught is NBA omega. Now if I want to plot a graph of this EMF with time, this is how it will look. This graph will follow a sin x graph with some constant. E is equal to E naught. Actually E is equal to E naught sin omega t, right? This is our function. So right, so ultimately this is going to follow our sine curve, which is like this. So it will change between plus E naught and minus E naught value. Okay, and these are the angle of rotation. You can see when theta is pi by 2 is going to touch the peak EMF. Just see this calculation. You will simply follow omega is 2 pi by capital T. Capital T is our one time period. When the coil rotates by just one round, that is that time, right? Time period. So you can see pi by 2 rotation. This will be peak again at pi rotation. Sin omega t will be 0. Right, and 3 pi by 2 again peak, but on the negative side, on the reverse side, and then 2 pi, it will be 0 again, and this will keep on repeating. So you will keep on, as you keep on rotating the coil, you will keep on generating EMF with the same pattern. This is why it is called alternating EMF, because it is changing its direction, also its value as the time changes, right? Okay, so if R is the resistance of the coil, we can also find the generated current in the coil. So I is equal to E by R. So it will be E naught sine omega t by R. So I is equal to I naught sine omega t. That's also the current. So E is equal to E naught sine omega t. That's EMF. And I is equal to I naught sine omega t. I naught is E naught by R. I naught is the peak or the maximum current. That's it. Thank you.